So here we go, answers to quiz 3. Very similar to quiz 2 with a few twists. Mark your own. Come on, Mr. Duick. Here we go. Come on, pen. My favorite student of all time, Ann Serkey. Identify as rational, irrational. Negative square root of 100. Rational, I agree, which our symbol for which was Q. By the way, what if it said this? I'm not going to give you one like this on the test, and I don't think they'll give you one like this on the provincial. You can't take the square root of a negative. Your calculator gives you an error. This is neither rational nor irrational. In fact, this is not a real number. It's an imaginary number. A complex number is the fancy-schmancy term. Found it, Curtis? You're good? You haven't found the quiz yet? You were here last day? I wonder if he did it. We'll find out. Rational, irrational, Q bar. Cube root of 9 is like 1 point something, 2 point something, but it goes on forever without repeating, right? Take the numbers below, fill them into the diagram below. Okay, negative 2.1, it's rational, but it's not an integer. Wait a minute, Mr. Dewick, it's negative. Integers are not decimals. It goes there. 10 over 5. Hey, what's 10 over 5 in lowest terms?
2.
It's a 2, which really means 10 over 5 is a natural number. It fits there, except that looks like a 0 over 5. Make the separate. Hey, Mr. Dewick, do this. Good call. That was clever. Ten over 5. Square root of 9. What's the square root of 9?
3.
Works out evenly. 3, and that is a natural number as well. It goes in there. 0.45. That's a rational number. The square root of 256. Square root of 256 is 16. Oh, square root of 16 is 4. Wow, this is also a natural number. Root of 256, because that's a 4. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8. I'll keep going. Whole numbers are, add a 0. Five over 4, rational. The fifth root of 25, not the square root of 25, the fifth root of 25. I think it's irrational because I don't think that works out evenly, but you should know how to do this on your calculator. If you don't, we'll review it later on, but it's the fifth root of 25. Yeah, it's 1.90365393. That's irrational. The fifth root of 25 is that. And remember, when we say that's the fifth root, what we're really saying is 1.90365 to the fifth power is pretty close to 25. Not bang on, you round that off. So 1 mark for each of those. True or false, there were no integers whatsoever in my list of numbers that I gave you. True or false, and convince me. Tell me why the answer is false. Yeah? No, that's not an integer, and it can't be. There are 4 integers in this diagram. Darian. Anything inside the whole numbers and inside the natural numbers is automatically an integer, right? Because integers swallow up wholes and naturals. So if I say to you there are no integers in this picture, actually there are. There are no only integers and not whole or naturals in this picture. I didn't give you like a -3, but there are 4 integers. You know how I know? Because there's 3 naturals and a whole, and both of those are part of the integer subgroup, right? Number 3, convert to mixed radicals in simplest form. 2 root 6? I shouldn't do these in my head. Well, that one, I can't do this next one in my head. This is going to be negative 3. What the heck goes into 392? I'm going to try 4. 98 does, ooh. You know what? I think I can take the square root of 392 evenly. I think, oh, it doesn't, no, I'm sorry. I thought it was a perfect square for a second there. It's not. Silly me, Mr. Dewick. So 392 divided by 4, and what perfect square is hidden in 98? Ooh. Yeah. I'm not done yet. What perfect square is hidden in 98? What perfect square is hidden in 98? 49 is not a 2 is not a perfect square. 49 is 4 and 49 are both hidden in 192. If I wanted to do this in one step, I would say the biggest perfect square that will work is 196. 196 goes into 392, and it's a perfect square. Amy, you can hopscotch your way by using the 4 and then looking at your answer and saying, oh, there's a 49 hidden at 98, and pulling out the 7. But I'm going to try doing this in one step. This is really root 196 root 2, because 2 times 196 is 392. This is really negative 3. What is the square root of 196? 14? Root 2. This is really negative 42 root 2. Half mark for the negative 42, half mark for the root 2. You got it? You okay? Yeah. You see, Alex, some of my kids, they like to memorize the big perfect squares and use those. I think that's great. But also some are like, well, can I just try the 5 and the 25 and the 6? You can, although 49 is one you have to try, because 49 is 7 times 7. There's no other perfect squares hidden in there. Two over 5. Okay, first of all, this is going to be 2 over 5. And what can I do with 2,400? Well, I definitely know that 100 will work, and that's a perfect square. But there's also a perfect square hidden in the 24. What's hidden in the 24? Are you saying a 4 and a 100 works? So what's the biggest perfect square that would work? If a 4 and a 100 works, 400. See how I can put it together? So I'm going to go back to here. I'm going to go 2,400 divided by 400, and I say, this is root 400, root 6, which is going to be 2, square root of 400 is 20, root 6 over 5. It's 2 times 20 divided by 5. 2 times 20 is 40 divided by 5. Sam, my friend, final answer is 8 root 6. Half mark for the 8, half mark for the root 6.
I got 4 root 3, so I took it down. The 8 I put into 4 and then 3.
The 8 you put into...
No, like I divided by 2.
Show me yours later.
Okay.
Easiest way. Root 150. 25 and... Root 25, root 6, 5, root 6. Half mark, half mark. Root 160, I think. Root 16, root 10. 4, root 10. Ooh, one with letters. AX root x to the 8th, a to the 7th. Okay. Well, Mr. Dewick, rewrite the a and the x. Is x to the 8th a perfect square?
Yes.
Oh, I can just take the square root of that. What is the square root of x to the 8th? This is going to become an x to the 4th when I square root it. Mr. Dewick, don't you take the square root of the 4th? No, I've taken the square root once. I don't keep going. I've done that. Is a to the 7th a perfect square? So how can I rewrite that? I can rewrite that as root a to the 6th, root a to the 1. Can I stop putting the 1 there? There's it, my a to the 7th. Why is that so nice? Because, Simi, I'm going to get ax, there's going to be an x to the 4th. What's the square root of a to the 6th? It's going to be an a to the 3rd and a root a left behind. There's going to be a root a left behind, and then I say to myself, self, how many a's are there? I think there's 4 of them. How many x's are there? I think there's 5 of them. I think it's a to the 4th, x to the 5th, root a. Half mark for the a to the 4th, x to the 5th, half mark for the root a. That's a tough question. Convert into an entire radical, going backwards. So what I'm really saying is, the root 10 I'm going to leave. That root 5 must have come from a root 25. How did I get the 25? I went 5 squared because it's square root. This must have been root 250. B, this must have been a 5 root 14 over 2, and then this must have been a root 25, a root 14, and a root 4, which is 25 times 14 on the top. Root 350 over 4. Does that reduce? What goes into the top and bottom evenly? Oh, this is going to be the square root of 175 divided by 2. You know what? This is going to be root 175 over 2. Can't go any further. That's a tough question. 2 root 5, convert into an entire radical. Okay, this is going to be root 4 root 5. You know what? This must have been a root 20. Uh, 6 root 7. This must have been a root 36 and a root 7, which is going to be the square root of 36 times 7. 3 times 7 is 210. 6 times 7 is 42. 252? Turn the page. Determine x in simplest radical form. Oh, they're pulling a little Pythagoras on me. Okay, Mr. Smarty Pants, I can do this. Pythagoras says a squared plus b squared equals c squared. Marcus, my friend, what has to go there always? Not the x. What has to go there always? The hypotenuse, which may be an x. It is in this case, but it might not be. You might know the hypotenuse. The x doesn't always go by itself. Let's see. This is going to be x squared, and this is going to be root 6 squared plus root 12 squared. And I'm going to make that look like a squared up there a little better. What is the square root of 6 squared? It's root 36, which is just plain old 6. And you know what root 12 squared is? Just plain old
12.
Are you telling me that x squared equals 16 plus 12? Or if I combine those, x squared equals
18?
what? Yeah. Jordan, how do I get rid of a squared? I got x squared equals 18. How would I get the x by itself? What's the square root? Yeah. Is your final answer 3 root 2? So if you got that, you get 2 out of 2. Otherwise, if I was giving out part marks, I'd probably give you a half mark if I saw that line, a half mark if I saw that line, probably a half mark if I saw that, and then a half mark for the answer. But if you got 3 root 2 and you didn't show every one of those steps, I'm good. I'll be honest, I usually can do these in my head. Although I probably wouldn't on a quiz or a test, because in my head I make mistakes. Hey, B was nastier than the previous nasty. Okay. I said I seem to recall that we needed to find that guy, that we were really solving two little triangles, one that looked like this, and then one that looked like this. And whatever we get for y goes right there. I said, you know what, I'll even draw a little line down the middle of my page to be organized. I'll solve the left-hand triangle first. I'm going to get root 2 squared plus 3 squared equals... No, Mr. Dewick, you don't put the y by itself. Marcus told you the hypotenuse is what always goes by itself. So the y squared's going to go there, and the 3 squared's going to go there. That's what you were saying, yeah? Hey, Marcus, what is root 2 all squared? So are you saying this is 2 plus y squared equals 9? How would I get the y squared by itself? Minus 2 from both sides? I think you get this. Y squared equals 7. Y equals root 7, which doesn't simplify. That's fine. But, Garrett, that helps me because now I know how long this side is. It's root 7, apparently. And now my equation's going to be 4 squared plus root 7 squared equals x squared. 16 plus 7 equals x squared. X squared equals 23. X is going to be root 23, which doesn't break down at all. Not every square root simplifies. So if you got the root 23, and I heard Naomi back, yay! 2 out of 2. Otherwise, I would probably go something like this. If I saw this somewhere, that would get you a half mark. If I saw that somewhere, that would get you a half mark. If I saw this line, that would get you a half mark. And then I would give you a half mark for the answer. Cube roots. Ah! No, relax. I can do this. Now I'm not thinking perfect squares. I know 32 is 16 times 2, but Sam, 16 isn't going to help me for a cube root. It would help me for a square root. For a cube root, I'm thinking, 8! This is 5, cube root 8, cube root 4. Still cube root 32. This is 5, what is the cube root of 8? 2, cube root 4. You know what? Final answer, half mark for a 10, half mark for a cube root of 4. B. Mr. Dewick, I thought you said you couldn't take the square root of negatives. You can't. Is this a square root? No. It's a cube root. You can't take the cube root of a negative. In fact, you know what? You can't take the square root or the fourth root or the sixth root or any even root of a negative. But for any odd root, a negative will work just fine. I'm going to rewrite this as negative 6 cube root of negative 125 cube root 2. Now, if you left the negative inside the root, that's going to be okay, but just have patience, and I'll tackle that in a second. I think you're going to get negative 6 negative 5 cube root 2. Do you get positive 30 cube root 2 as your final answer? That is correct. We added a couple of questions too, didn't we? Okay. If you left 30 cube root of negative 2, I will give you full marks, but can you see you could have actually pulled the negative out by making your perfect cube a negative. It's cleaner. You would have had a negative 30 in front and a negative cube root of 2 still left inside the brackets. Okay, what were my other questions, Mr. Dewick? I probably put them under block H, I bet you. And I probably want to go find quiz 3, Mr. Dewick. And let's make this a little bit smaller. Let's use my little lasso trick. Copy. Paste. Here we go. Write as an entire radical. Okay. Well, there's going to be a cube root of 10. How can I write a negative 6 as a cube root? Sorry? Negative 216. How'd you get that? You're right. How'd you get that? It really is going to be negative 6 cubed, and the fact that that and that are both 3's is not a coincidence. For this fourth root, I'm going to use 5 to the 4th inside. If there was a 5, it would be 5 to the 5th. Anyways, this is going to be the cube root of, I agree, it's negative 216 cube root 10, which, Darian, I'm pretty sure is the cube root of negative 2,160. Yes? Yes. 1 mark. If they wanted me to write this one as an entire radical, I would say to myself, okay, this is going to be 5 to the 4th. That must be where that 5 in front came from. 4th root of 3. 5 to the 4th, I think, is 625. I think.
Yep.
And so you're going to get the 4th root of, let's see, 600 times 3 is 1,800. 25 times 3 is 1,875? Woohoo! There you go. 1 mark for that. So that makes this quiz, we said, no longer out of 28. That makes it out of, count 'em, 3, 0, 30. Can you give yourself a score out of 30, please?